Now let's continue to further solve logarithmic expressions. And in this case, we want to see if we can expand and condense logarithmic expressions. So we still going to apply those three rules that we were looking at before. And we've sort of kind of already have been doing this, expanding and condensing our expressions. So if you'll notice on the left-hand side of the equation, this is considered to be the condensed form, and that's because you can see we just have one log here. But over on the right-hand side, this is considered to be the expanded form, and that's because you can see we have more than one log over here on the right-hand side. So if we want to expand, then we'll go in this direction, but if we want to condense back down to just one log, then we'll just simply go back in the opposite direction. So now let's take a look at this example here. We have log base 8 of 64 over the square root of x plus 1. And we want to see if we can expand. So it makes sense that we want to expand because we just have one log here. Well, if we look at the operation that's going on here, we have something being divided by something. So anytime we are dividing, then we know, well, that's just going to be the quotient rule. And we know the quotient rule just says anytime we're dividing, we can separate into two logs by using subtraction. So we're just going to rewrite this so that we can take log base 8 of our top function minus log base 8 of our bottom function. So now that we have it expanded, we now can see if we can simplify this as much as possible. So now let's take a look at this first part of this expression. You notice we have a base 8, and here we have our value here is 64. So we want to see if we can try to rewrite 64 as this base to some number. So let's see if we can write 64 as 8 to some number. So of course we know 64 is the same as 8 squared. Now let's take a look at what we have on this side. We have log of 8, the square root of x plus 1. Well, you can notice we have this radical here. So let's see if we can rewrite this x plus 1 to a power. Well, if you remember, if we have a square root, we can rewrite that as an exponent as to the 1/2 power. So now you'll notice we have two powers going on here. We have a square here, and then we have a 1/2 here. Well, that should remind you of the power rule. So if I have a power, remember I can bring that power to the front and multiply it by my log. Well, now that I have my exponents being multiplied by my log, let's now see if we can simplify even further. So if you notice here, I have a log base 8 of 8. So if you remember one of those basic rules, anytime my base is the same as this value here, well, this entire log is equal to 1. So therefore, with this first piece here, this first term, I really just have 2 times 1. There's nothing that we can do over here. We can't simplify that any further, so this term will stay the same. So here I just have 2 times 1, which is 2. So therefore, the simplified answer for that expression in the expanded form would just simply be 2 minus 1/2 of log base 8 of x plus 1. So now let's look at a few more examples in which we have to expand the logarithmic expression. So here we have a natural log of the cube root of e to the x. So let's first see if we can rewrite this. Anytime we have a radical, let's rewrite what's under the radical as that value raised to a power. So we can simply rewrite this ln of the function underneath the radical e to the x raised to the 1/3 power because we had that cube root. Kind of like when we had the square root, we had it to the 1/2 power, so this time it's a cube root, so 1/3 power. Now, since we do have that power, remember we can apply the power rule. So we'll just bring that exponent to the front and multiply by this natural log. So now we have this 1/3 being multiplied by our natural log function. And now let's see if we can expand what we have inside here. Well, you can see the operation is multiplication, so that's the same as a product. So anytime I am multiplying two functions together, I can separate with a plus, with addition. So therefore, we have 1/3 being multiplied by the ln of e plus ln of x. So if you notice here, there is no base that's given, right? But we know with the natural log, the understood base is base e. So let's rewrite it with the base e written there. So now you'll notice if you look at this first term here, my base e is the same as my function or my value here. So if you remember, anytime those two numbers are the same, well, this entire thing will just be equal to 1. So now we can just distribute our 1/3 through and simplify and have our final answer. And so therefore 1/3 plus ln of x would be the final answer. And you will note that you don't necessarily have to write that base e in there, but you can keep it if you like. Let's now take a look at our second example here. Log base 2 of the 5th root of x times y to the 4th over 16. So again, we have this function under a radical, so let's see if we can rewrite this function raised to a power. So we now have everything that was under radical now raised to the 1/5 power. So since we have a power, we know we can apply the power rule. We'll just bring that exponent down to the front. So we first can begin writing by the 1/5 in front, log base 2 of my top function. Now the operation here is division, so we know we can expand with subtraction. So we have 1/5 times log base 2 of x times y to the 4th minus log base 2 of 16. Now if you take a look at what we have going on with this first term, we have multiplication, so it looks like we can expand this piece even further. Here we have this 16, we have a base of 2, so we want to see if we can rewrite 16 as 2 to a power. So now we have the first term expanded using the product rule. With the second term, we just rewrote 16 as 2 to the 4th power, which is the same as 16. Now let's take our 1/5 that we have out here in the front. Let's multiply that by each of those log terms. Now that we have the 1/5 distributed through to each term, we'll notice on the last two terms we have powers, we have exponents. So that means we have to apply the power rule. We're just going to bring those exponents to the front, and then in this case we'll multiply it by that coefficient in front of each of those log terms. There's nothing we can do with this first term, so it's going to stay exactly as it is. So we have just rewritten the first term exactly how it is. We brought the 4 down to the front, multiplied it by the 1/5, so 4/5 log base 2 to the y. Then if you look here, we bring the 4 down, multiply by the 1/5, but then you'll notice we have log base 2 of 2. Well, again, anytime those two values are the same, we know that's just equal to 1. So therefore, we really just have 1/5, which was times the 4, so we really just have 4/5 times 1. So we can leave that last term as 4/5. So this would be the final answer of that expression in the expanded form. Now let's suppose we want to go in the opposite direction, and let's suppose now we want to condense the logarithmic expressions. So if you look at this first example, you can see that it's in the expanded form because we have two logs here, and we want to condense it down to just one log. So if we take a look at this first term, we have 2 times log base 6 of x. Well, we see that we have this constant here, that coefficient in front, and so we kind of just want to go in the opposite direction. If it's being multiplied by this log, then that means it must have been an exponent. So we're just going to rewrite it back as an exponent on this x, and we're going to do the same thing for this 3. We're just going to put it back as an exponent. Now you can see here we have this plus, and remember with addition goes with the product rule, so multiplying. So we're going to multiply our functions together. So therefore, putting everything back together in terms of just one log, we have now condensed it down to just log base 6 of the two functions being multiplied together, x squared times y cubed. Now let's take a look at our next example here. Again, we want to condense it to just one log. In this case, we have the natural log ln, and we want to condense it down to just one natural log. Again, you can see that we have this coefficient in front. Since it's been multiplied by that ln, then we're just going to put it back as an exponent. Same thing with the 3 here, put it back as an exponent. Then you can see we have this minus here, and we know with subtraction is division. So we're just going to apply the quotient rule. So now after putting the exponents back, and now applying the quotient rule with the minus, we know to now divide the first term over the second term. And so this would be our final answer for the condensed form of that log expression. Now finally, let's look at this last example. So again, we want to condense. Again, you can see we have that coefficient in front. We're going to put all of these coefficients back as an exponent. Then we're going to take a look at the first two terms and condense those down to just one natural log. Since we have that minus there, we know with minus goes with division, so we're going to apply the quotient rule and the power rule with those first two terms. Now, after applying the power rule and the quotient rule with these first two terms, we now still have two natural logs that we want to condense down to just one natural log. So you can see we have this plus in the middle. We know with plus goes with product rule, multiplication. So we're going to apply the product rule here. And also, since we have this b to the 1/5 power, we're just going to rewrite it so that it's now at a radical. So we're going to put the b under the radical. This is the 1/5 power, so that radical is going to be the 5th root. And so now you can see we applied the product rule. We multiplied the first term by the function of the second term, so the a cubed times c squared, and then we put b back under the radical. So we have it there under the radical for the 5th root. So this would be your final answer of the condensed form of that natural log.